The National Electrical Code, specifically Article 300.34 D2, addresses the minimum bending radius for stranded conductors. For insulated conductors with stranded copper conductors, such as THHN wire, the minimum bending radius is specified as 4 times the outer diameter of the conductor. Let's break this down with an example. Consider number 12 THHN wire. According to wire tables, a number 12 THHN wire has an approximate outer diameter of 0.216 inches. To determine the minimum bending radius, you multiply this outer diameter by 4. So, the calculation is 4 times 0.216 inches, which equals 0.864 inches. Therefore, the minimum bending radius for a number 12 THHN wire is 0.864 inches. It's important to understand why this bending radius is crucial. Bending conductors too sharply can damage the insulation, potentially leading to shorts, ground faults, or even fires. Maintaining the minimum bending radius ensures the insulation remains intact and the conductor's electrical properties are preserved. Now, let's delve deeper into the implications of NEC Article 300.34 D2. This section is designed to provide a safe and reliable electrical installation. Bending conductors improperly can create stress points, increasing the risk of insulation breakdown over time. By adhering to the 4 times the outer diameter rule, you minimize these risks. Keep in mind that the outer diameter of the conductor includes the insulation. When measuring the outer diameter, use a caliper or micrometer to get an accurate reading. An inaccurate measurement can lead to an incorrect bending radius calculation. It is also essential to differentiate THHN from other types of cables such as Romex. Romex, or non-metallic sheath cable, typically has a different bending radius requirement. The minimum bending radius for Romex is generally 5 times the diameter of the insulated conductor, not just the conductor itself. This difference arises from the construction of Romex, which includes multiple conductors bundled together within a sheathing. When working with different wire sizes, remember that the outer diameter varies accordingly. Larger conductors will have larger outer diameters and, consequently, larger minimum bending radii. Always consult the wire manufacturer's specifications or a wire gauge chart to determine the correct outer diameter for the specific conductor you are using. Incorrectly estimating the outer diameter can lead to improper bending. Furthermore, consider the tools you are using to bend the conductors. Using proper bending tools, such as conduit benders or cable benders, can help you achieve the desired bending radius without damaging the insulation. Avoid using makeshift methods or tools that could potentially compromise the integrity of the conductor. Here are a few additional tips to keep in mind when bending THHN conductors. Firstly, always de-energize the circuit before working with any electrical wiring. Secondly, inspect the conductors for any signs of damage or wear before bending them. Thirdly, use a lubricant if necessary to reduce friction during bending. Fourthly, avoid kinking or sharply creasing the conductors during bending. Fifthly, ensure that the bending radius is consistent throughout the bend. Sixthly, use appropriate personal protective equipment, such as gloves and eye protection. Seventhly, double-check your bending radius calculations before making any bends. Eighthly, if you are unsure about the correct bending radius, consult with a qualified electrician. Ninthly, adhere to all applicable local and national electrical codes. And tenthly, document your work for future reference. Let's explore a few more examples to solidify your understanding. Suppose you are working with a number 6 THHN conductor. According to wire tables, the outer diameter of a number 6 THHN wire is approximately 0.375 inches. To calculate the minimum bending radius, you multiply 0.375 inches by 4, resulting in a minimum bending radius of 1.5 inches. Another example involves a number 10 THHN wire. The outer diameter of a number 10 THHN wire is approximately 0.190 inches. Multiplying 0.190 inches by 4 gives you a minimum bending radius of 0.76 inches. These examples illustrate how the minimum bending radius varies with the size of the conductor. Always verify the outer diameter for the specific wire size you are working with. Now let's discuss the importance of proper support for bent conductors. After bending conductors, ensure that they are adequately supported to prevent stress on the connections or terminations. Use cable ties, clamps, or other appropriate methods to secure the conductors in place. Improper support can lead to loosening of connections, which can cause overheating and potential fire hazards. In addition to the minimum bending radius, there are other considerations when working with THHN conductors. Firstly, ensure that the conductors are properly sized for the intended application. Secondly, use the correct type of connectors and terminals for the conductors. Thirdly, protect the conductors from physical damage. Fourthly, avoid over-tightening connections, which can damage the conductors or terminals. Fifthly, properly insulate all connections and splices. Sixthly, label all conductors and circuits for easy identification. Seventhly, regularly inspect electrical wiring for any signs of damage or wear. Eighthly, address any electrical issues promptly to prevent further problems. Ninthly, consider using a surge protector to protect sensitive electronic equipment. And tenthly, consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Let's explore some common mistakes to avoid when bending THHN conductors. Firstly, do not exceed the maximum fill capacity of conduit or enclosures. Secondly, avoid using damaged or corroded conductors. Thirdly, do not mix different types of conductors in the same conduit or enclosure. Fourthly, do not overload circuits, which can cause overheating and potential fire hazards. Fifthly, do not use extension cords as permanent wiring. Sixthly, do not cover electrical pals or outlets with furniture or other obstructions. Seventhly, do not ignore warning signs such as flickering lights or buzzing sounds. Eighthly, do not attempt to repair electrical equipment without proper training and experience. Ninthly, do not allow water or moisture to come into contact with electrical wiring. And tenthly, do not bypass safety devices such as circuit breakers or ground fault circuit interrupters. The minimum bending radius is just one aspect of safe electrical practices. It is essential to have a thorough understanding of all applicable codes and regulations to ensure a safe and reliable electrical installation. Working with electricity can be dangerous if not done correctly. If you are not comfortable working with electrical wiring, it is best to consult with a qualified electrician. They can provide expert guidance and ensure that the work is done safely and correctly. Remember, the goal is to create a safe and reliable electrical system that protects people and property from electrical hazards. By following the guidelines outlined in the National Electrical Code and adhering to safe work practices, you can minimize the risk of electrical accidents and ensure the long-term performance of your electrical system. Now let's reiterate the key points covered in this discussion. The minimum bending radius for THHN stranded conductors is 4 times the outer diameter of the conductor, as specified in NEC Article 300.34. D2. Always measure the outer diameter accurately and use the correct bending tools to avoid damaging the insulation. Remember to support the bent conductors properly to prevent stress on connections. By adhering to these guidelines, you can ensure safe and reliable electrical installation. Furthermore, it is essential to stay up to date with the latest revisions and amendments to the National Electrical Code. Electrical codes are constantly evolving to reflect new technologies and safety standards. Regularly reviewing the code and participating in continuing education courses can help you stay informed and ensure that your electrical work is always in compliance with the most current requirements. In addition to the NEC, local codes and regulations may also apply. Be sure to check with your local authorities to determine if there are any additional requirements that you must follow. Compliance with both national and local codes is essential for ensuring the safety and legality of your electrical work. When in doubt, always consult with a qualified electrician or electrical inspector. They can provide expert guidance and help you navigate the complexities of electrical codes and regulations. The information provided in this discussion is for general informational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. They can assess your specific situation and provide tailored recommendations based on your individual needs and circumstances. Working with electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Remember, safety is always the top priority. By following the guidelines outlined in this discussion and consulting with qualified professionals, you can ensure that your electrical work is done safely and correctly. The knowledge of electrical concepts and practices are paramount for ensuring safe operations. Understanding the relevant electrical codes, proper selection, and installation of materials are all essential steps. By following these concepts, you are not just performing a task but contributing to the safety and reliability of electrical systems. This is critical for everyday life, from powering homes to facilitating industrial operations. It underscores the importance of continuous learning and adherence to safety standards in the electrical field.